What's up, gangsters? How about some minutes of random? All right, this is going to get back to the spirit of 10 minutes of random, hopefully. Probably not in the literal sense of being actually 10 minutes long, because since when has that ever happened? But anyway, it'll be random because it's going to be about a bunch of different things. The last couple of times I've done this, it's really been all about that thing, the Hornet, and it will be a little bit, but I took a break from that after I finished all the ordnance and did this Viking Bust. I did a separate video about it, so I'm not going to say a whole lot, but this is a lovely 3D print. I think this is 1/6 scale. This is a digital sculpt from a fabulous artist over in the UK called Laven Archer. He's got a Facebook page. You can find him on ArtStation. You can buy the STL file in several different places. But this was really a pretty cool, fun project for me to just kind of, again, try and improve my figure painting chops. And if you watch the video I made about it, maybe you will see that I also learned a few things. But I finished that, and I did come back to the Hornet, and feels good to be back on it, mostly. Have already had a couple of frustrations. This thing has been sitting, doing nothing for about 6 weeks, and no, more than 6 weeks, about 3 months. And one of the first things that I noticed was that I had some ghost seams going on. There are there were 4 places. Back here, right there around where the tail feathers poke in, there's a seam there. That had some ghost seamage. The infamous joint right here at the nose that runs straight horizontally from the front of the lex, that had some ghost seam stuff going on, and it was on both sides. I think I used a little bit of sprue goo in both places, so I'm sure people will be like, oh yeah, well that's the problem. Yeah, not so much, because it was very little, and I have found that ghost seams can happen when there's nothing but extra thin at play. And I know some people want to use super glue for that reason. I'm never going to do that. I prefer a weld as opposed to an adhesive joint, and super glue really is more of a mechanical joint anyway. It's not even really an adhesive anyway. But point being is, I just, it's probably a good thing that I was moving so slowly on this, because it gave it time to age properly, and for those ghost seams to make themselves known, and for me to be able to call Ghostbusters and fix them, which in this case was just a simple application of the ultralight brush-on filler, also known as Goopy Old ALC 309 lacquer primer, that I keep around in this bottle for exactly that reason. I also used it to fill in the rivets that I punched in this little panel right here in front of the nose. That stupid panel, that thing was a hard deal to scribe correctly across the joint there in the fuselage. And I got to looking at reference photos, and the rivets there show up pretty well, or maybe they're Zeus fasteners or something. I don't know what that panel is actually for. But I just failed, and I redid it, and I failed again. And so yesterday I finally just said, you know what, fuck it, I'm just not going to do it. They look like shit. I can't get the spacing correct. So I just filled them in and sanded them off, and that's why that looks like that. The other thing that's going on that's been a bit frustrating, because of course, here I am down to the very end of getting all the body work done and feeling like I'm about ready to do some real painting, has been the windscreen and the canopy. Because while it has been a perfect fit all around the front, you can see really good. There's a little bit of a gap right there at that corner, maybe just a slight short shot or something. So I'm working on filling that in with some black super glue. But the real problem was that right here at the back of the thing, it was too narrow by a good 0.5 millimeter. So what I ended up doing, and this is fraught with anxiety, because anytime you start, forcing clear parts into position, you run the risk of developing stress fractures like I had on my F4. But I tested it and there wasn't really much force involved. So what I did is I glued the left-hand side, let it set up overnight, get really firmly welded in place with extra thin. Then I carved a wedge out of a toothpick and jammed it in there in between the edge of the instrument panel and the inside of the face of the windscreen, enough to shove that bottom edge over to the right spot, and glued it in place. And that worked fine. And so I was like, all right, that's cool. But then I stuck the canopy on, and it was even worse. Perfect fit here at the back, and almost a millimeter too narrow at the front. So what to do? Well, again, I'm trying some gentle persuasion. I did some measurements, and thanks to a good suggestion from Chuck Morford in SMCG, I cut this spacer to the right length. It's spreading the two sides of the canopy to the proper amount, to where you can see when I drop it on here that is pretty bueno on that side, and pretty bueno on the other side. You can see pretty good. And so you're asking, well, how are you going to get it to stay that way? Well, what I'm hoping is that a little time and a little warmth will do it. So I've been leaving this thing out in the sun in my window, which gets warm, not enough to melt it or do anything crazy. But, there's a time and temperature relationship with plastics. And even at a low temperature, you give it enough time and it'll relax into a new position if you got a little bit of force on it. So that's what I'm hoping will happen here. I checked it yesterday after 2 days, and it's about halfway there. If it doesn't get there by the time I need it to be, then I will apply a little more aggressive heat using a heater, or my blow dryer, whatever it is. And I think we'll get it there. The other thing that you can see pretty clearly, though, that I'm going to have to just do a little bit of basic sanding and filing work, is that gap between the windscreen and the canopy. It's pretty disappointing because, look, not everybody is automatically going to pose this thing open. And that's, of course, always the excuse. Well, it's made to be posed open. Yeah, no. That shouldn't matter. And I don't think that this is bad engineering. I think that this is just a case of this. These are parts that are prone to warpage at that front edge once they take them out of the tool. So maybe it's a process issue. I don't know, but it clearly escaped quality control, either because they didn't notice it or they didn't care. But it kind of fits in with the sort of thing I've been saying about this kit, that overall it's pretty nice, but it's really only about an 80% kit because of stuff like that. Not a major issue for a lot of guys. They're not going to worry about stuff like that. But if you really want it to be, refined in terms of fit, yeah, it's going to cost you some time and some energy. So anyway, but that's that. I've been on to some other random things. I'm working on a CAD design project for a tractor that I really want to build, that I'm hoping to actually, it started out as doing nothing but the wheels, and it's turned into, I'm going to just design the entire kit. And so I ran my first 3D print of some of the parts last night to check fit. This is one of the tires, wheel, axle parts. And I'm not going to get into it too much right now, but this is a fail because there's supposed to be lettering. You can sort of see it sort of subsurface there. That's all supposed to be sticking up. And this is a fail, obviously, because that whole top surface is kind of flat. And what happened there is that you can see the raft is way thicker than it should be. It lifted. And so that caused some of those upper features to be buried. Didn't have to lift much because they were only sticking out like 0.15 millimeters. So yeah, that's annoying, but this is really just a fit check print so that I can see that all of my diameters are good. Speaking of 3D printing, this is something that's been sitting here on my bench from a long time ago that I never talked about. This is a successful print. This is a joystick that Fanch Lubin created for his Tiger Cat. And this is just an example of what can be done when everything goes right. I don't know if you'll be able to see it or not, but there is a texture pattern in the side of the grip there. And this is 1/32 scale. There you can maybe see that cross-hatching diamond-shaped pattern that actually resolved in my little Epax X1 4K mono. Pretty cool, really cool stuff. Again, these printers are amazing in what we can get away with. Something else that's been on my bench of things to tinker with is my continuing effort to solve the bare metal foil problem. And I had some new material that I got. Let me slide over here and get the box so you can see that. And I got that because of a suggestion from somebody to go find some aluminum shim stock. So that's what this is. I got this from McMaster Carr. This is 1/1000 thick or 0.25 millimeter thick aluminum shim. Now, what's different about this, other than it was $25 for this 6-inch by 50-foot roll, and it comes from an industrial supply place. So what's different is that it's a different alloy and a different hardness condition. Aluminum foil is typically like an 1100 series aluminum, basically pure aluminum almost in the dead soft condition. And that's great that it's dead soft because it conforms to all of these details pretty well. It's pretty easy to burnish it, but it's practically impossible to polish because it tends to spall. In other words, it sort of smears around rather than cuts. And it's really susceptible to damage. I mean, this took a tremendous amount of work to get this result, which doesn't look terrible, but it took a shit ton of sanding and polishing, and it's not terrible, but it's really easy to damage. Like I can run my fingernail across it and put a scratch in it that's going to be almost impossible to completely get rid of. So the difference with shim stock is this is a 1235 aluminum that's hardened, fully hard to the H19 condition. And you can really kind of hear it. Like it just, it has a more of a ring to it because it's harder. And so I thought, well, this will polish better, and it may not, because it's not as malleable, it may not reveal things like glue texture from underneath quite as easily. And so I finally got around to applying it to this test piece, and yeah, this is pretty compelling because everything that I thought about it is true. You can see the level of polish is amazing. I mean, from even, far away, you get good reflectivity. It's kind of wavy. There is some glue texture under there, but it's not lumpy and nubbly like it's been with the softer aluminum. So pretty cool. Here's the really great thing. I didn't sand this at all. This is nothing but Mother's aluminum wheel polish run for a few seconds with my Proxon and a polishing wheel, and it buffed up immediately and looks amazing. Now you may say, well, okay, Pattison, why do you want it to be that reflective and shiny? That's not really what they looked like under normal use. Yes, you're not wrong. What I'm trying to get to is what this sheet material looked like straight out of the factory. But the first thing that I have to do is make sure there's no texture at all. I just can't compromise on this. No texture. And the easiest way to do that and to be able to see it is to go to a full polish. And then I can go backwards by rubbing it down with something like a polishing stick, like, let's see, like this thing right here. Well, even a really light sanding, like, let me see here. I got a 2500 grit thing here in my... Okay, so here's a 2500, no, that's 1000 grit, whatever. It's pretty worn out. We'll just see what it does. So I can come back and I can rub that down to where it's got that sort of hazy but reflective look that these aluminum sheets would have. All right, so now you can kind of see what I'm after. So that takes some of that shine off. That took off more than I really wanted to, but you get my point. I can mask off panels. I can selectively work on them to get the grain going in different directions. I can basically do pretty much anything I want to from that fully polished sort of mirror-like condition, and that's what I'm after. So this is really compelling, but what's the bad news? Well, yeah, everything I said about it being a harder material and the fact that it's thicker is true. But it also means that it will not pick up the underlying detail very well. These panel lines were really kind of difficult. A toothpick just wouldn't work. And so I just was kind of poking around to try to find something. And I ended up using this end of this little tool because it's got it's pointy and sharp enough, but not going to cut, and it's smooth, so it doesn't snag. And I was able to work in those panel lines pretty well by doing that. But the rivets, yeah, no amount of burnishing with a piece of wood or whatever would really get the rivets to show through in the same way that I was able to with this stuff. And I think even with this, I was going to have to probably punch the rivets again anyway. So that's kind of a wash, but that's a problem I'm going to have to work on separately. We'll see what happens. The bottom line though is that if I can get this in a thinner material, this is a 1/1000 of an inch thick. Kitchen foil is typically 50 to 60, is typically 0.6 to 0.7 mils. So instead of 0.001 inches thick, it's 0.0006 inches thick. Heavy duty kitchen foil is typically about 0.8 mils. A mil is 1/1000 of an inch, if that's not clear. Anyway, so this is a bit thicker even than heavy duty kitchen foil. If I could get this same stuff at 0.6 mils, it might just be magic. I don't know. I've got to do some investigating. It's Monday morning. I haven't got on the phone yet, but that's what I'm going to try to find. So I think that's got some hope. Now, back to the paint thing. Here's something else that I tried out. This is a sample of some paint that's all the rage on the prop forums. Like, you'll see dudes painting the Mandalorian's helmet with this stuff, and it's like $180 for a quart. Extremely expensive. Somebody was kind enough to send this sample to me. I can't turn the bottle over very well for you to be able to see it because I had to drill holes in the lid because I couldn't get it open. But this stuff smells exactly like AK-477. I mean, literally identical to this stuff. And they behave almost exactly the same. So I'm kind of led to believe that this stuff, and I forget what it's called, it's a Luma something. But anyway, I'm just not impressed. This is how it came out when I painted it. I sprayed a nice glossy layer of Guns GX2 so that I'd have that sort of, as a basis to test it on, because that's kind of the standard thing when you're doing a chrome-like finish. but I sprayed it across the gloss, the bare plastic, and this sanded primer area, and you can see the differences. What I found was interesting was that it's actually pretty hot, and I was really flooding it on right here just to see what it would do, and you can see that it sort of started to craze, whereas right here I went a little lighter. This is still 4 layers, and it did not craze or do anything weird, but it's also just not that great. This is not even as chromy as AK-477. I mean, it's kind of reflective, but not much. And I'm sure somebody's going to say, oh, well, you did it wrong. Yeah, well, whatever. I did it the standard way, and it's just not that great. I mean, I honestly, I would pick the AK stuff over this. I don't know about durability. I sprayed this yesterday, and just kind of rubbing on it with my finger. It's not easily coming off, but it's certainly changing the way it looks a little bit. I mean, it's, in terms of durability, it's not too bad. This is, again, it's about the same as AK-477. Here's something that I find really more fascinating, though, than all of that. Look at these little lines, all right? They come off of each one of those rivet holes. So what's going on there is this paint is hot enough to where you see the differential properties of the styrene showing up because of different flow conditions and cooling rates inside the tool. But what's neat is, see, the gates on this part are here on the leading edge. You can see these are called sub gates because they go below the parting line. So you're blowing a lot of material in there, very hot, very fast, very high pressure. And every one of these little rivets is a pin sticking into the tool. And so that wave front hits those pins and creates this kind of little shadow, which I think is pretty neat. Just fascinating, if you're an engineer nerd like me. Anyway, that's enough. I was shooting for 15 minutes. That's 22 minutes of random, so gotta go. Bye.